Hello guys, today I am going to show you that how to find the solution, means what is the solution and approach to take for the question number 42 of the lead code, which is trapping rainwater. Okay, so here the question is that given n non-negative integers representing an elevation map where the width of each bar is 1, compute how much water it can store, means it can trap after raining. Okay, so first of all, the height is, means in input you just open question number 42, which is the hard level question. I'm just dictating and telling the approach. Okay, so the height over here is given is, means the array with name height is given, which is equals to 4 2 0 3 2 5. Okay, so first of all we can draw a graph like this. I hope it would be clear. Yeah, see, so here it is given of 4. Okay, then it is given of 2, then 0, then it's 3, then it is again 2, then it is 5. Okay, 5. And see, in the, when you solve any question, no, when it is given in the question, any hint which is given, like here it is given in the question, it is given that width of each bar is 1. So I would like to suggest you that read each and every line of the question very carefully, because every line is trying to indicate you something. So here if the width of bar is given 1, so that is also trying to indicate something. Okay, so before moving ahead, let me just tell you that what do you understand by the concept of trapping rainwater. Means what is trapping rainwater? Trapping rainwater means, suppose that here is, it's a bar kind of structure which is created, and suddenly cloud comes and it starts raining. So these type of bars are created over here. So tell me that how much water is going to be trapped in these bars. I can take this example as a building. Suppose too many buildings are there in a colony, and just you have to assume it. I'm just trying to explain you through assumption. And in that building, if it is standing in a row and it is raining heavily, so how much water can be trapped after the building, the spaces which are vacant for before another building. Okay, so now trapping rainwater, does it make sense? Like when you make complete, does it make sense like when the bar is going to be in decreasing order like this? So is it ever going to trap rainwater inside it? No, it's never going to trap, because suppose when water comes, it is going to be slided like this, means it's never going to be stored. And suppose when it's going to be in increasing order, see, when it is in increasing order, is it ever possible that the water can be trapped? Never possible, because the trapped water will again fall. And one more thing, that is it ever possible for one building, means for one bar, to store the rainwater? No, it's never possible. One bar can never store the rainwater. So what do you get from these three examples which I have tried to show you? That it's very important for the valley formation. It's very important for the valley formation, for the trapping of rainwater. Like if the valley is formed, it doesn't matter both are of same height or not, but if the valley is formed, then we can find the water trapped inside it. Okay, so now moving ahead, now what I can do. So I want to tell you that which points got cleared up over here. First point, that in the decreasing order the water can never be stored. In the increasing order the water can never be stored. A single bar can never store the water. It's very important for the valley formation for storing the water. You get this much? So now see, here when you are seeing that when it is like 4 2, here 0 3 2 5, the height array is given over here. The test case which I am taking is this. So just apply your brain now. that here you can see the valley formation is there. So just tell me one thing, that how could you think, like it's a hard level question, but means it would be containing a bit more concepts, right? That's why it's hard level. So can you think of like how to think that how much water is going to be trapped? See, if the height, I want to just suggest you one thing, that if the height is 4 over here and the height of this bar is 5, okay, this bar height is 5 and this bar height is 4, so the water can be stored till here only. Don't you think that it is not going to store water above it? Why? Apply your brain over here. If it is going to store the water above it, so from the left side also there should be the bar which could contain the water inside it, right? Like for example, let me take the example of a glass. Okay, so for the glass, like see, when you have to store the water inside it, so what do you think, that if only one surface is going to be there of, suppose one surface of the glass is the container, the glass is having the height of 4 centimeter and the other surface is having the next means the surface, other surface is having the height of 8 centimeter. So what do you think, that how much water is going to be stored? It's going to be stored till 4 centimeter only, because for more water to be stored above 4 centimeter, you need both the sides so that the water could be contained between them. So similar is the example over here. So basically what I am trying to tell you over here is that for storing the water you have to think in this manner, that you have to like from the left bar and from the right bar, means the minimum, like 4 is the minimum, so maximum water which can be stored is till this much only, 4. Okay, so from here you can easily get that we took out the left max, means the maximum water how much it can store, and then I am trying to take out the trapped rainwater. So first concept which comes over here, that you have to take out the left maximum. From the left, what is the maximum, and that much water is only going to be stored over here. Now from the right, we are going to take out the right max. So after taking out the right max, we will take out the minimum of left max and right max, and it will tell, and the third point will be that we will take out the minimum of left max and right max. Why minimum? Because as I told you with the example of the glass, that the minimum water which can be stored is the minimum of left max and right max. So the third concept is that you have to take out the minimum of left max and right max for trapped rainwater. So now you got the 3 approaches, like you have to think the question in this manner, because in the interview if you are going to sit, then they are not going to ask you the repeated question, right? The question patterns can get repeated, but the logic you have to, the pattern you have to identify, right? So here the what basically I am trying to explain you is that what the pattern it is following over here. Okay, so taking out left max, taking out right max, and the minimum of left max and right max is going to give you the stored rainwater. Okay, so for example, if seeing the example of over here, so how much water will be stored over here in this part? Because in the leetcode question, just see this part, that how it is over here. This one is the bar, okay, and the space which is left inside it gives the valley formation, so that much water is going to be stored over here. Then moving to the next bar, and the above it can't store. Now moving to the next bar, the valley formation which is over here gives you how much rainwater is going to be trapped over here, right? So in the same manner, if I have to take out it, so here how much water is going to be stored? 4. After taking out the minimum of left max and right max, now 4 water. Now here the minimum height is 4, like minimum height is 4, and here 2, till 2 it's the bar. Okay, so we will minus 4 minus 2, it will be 2, so 2 centimeter water is going to be trapped over here. Now moving towards here, it's 0, so again 4. Now moving towards over here, it's 4 minus 3, it's 1. Okay, and now you have to see the pattern over here in the similar manner, and after deducting it over here, like in this question I have left the spaces for explaining you clearly, but here in the question you can see that all the after every bar spaces are not left over here. See over here, the spaces is not there. So for if the spaces is not there, so wherever in between the bars the spaces are there, you have to calculate the stored water over there only. Okay, so here the spaces was there, so here you have to calculate it, and here the difference is there between the two bars, you have to calculate it. Now when there's no space between the two bars, there nothing, like no water is going to be stored. Moving to the next, there is like this much difference, then that much water is going to be stored over here. I hope you would be getting it. So now moving ahead, so in this way we take out the trapped rainwater. Now moving towards the question, that how we are going to attempt this question basically. So let me just move on to the next page and just create this graph. I'm just creating this graph, small graph only, once again. So that when I'll take out the minimum of left max and right max, then you will be having the clear concept over here. Okay, so it is the bar is I'm taking over here is of 4 size. Suppose 4, I'm taking this much, sorry, 4, 2, and after that it's 0, then it is 3, then it is 2, and then it is 5. Okay, so I have taken this, and the area you have to keep in mind that the area of the bar is 1, means the area is same. I'll tell you later that why the area is same over here, means what this line indicates. Okay, so first of all I am taking out the left max of every array. The height of the array is given over here, it's 4, 2, 0, 3, 2, 5. Okay, so now I am telling over here that I am going to take the maximum of left max. For taking the maximum, what I'll do, I'm going to take it like I'm going to my first step is going to be creating the left max. So how I'm going to create the left max, I'm breaking each and every steps into smaller parts so that the things becomes crystal and clear to you. For taking out the left max, I'm telling that I'm going to apply the for loop from I equals to 0 till the height dot size. Okay, whatever would be the size of this, and I plus plus. Now I'm going to take out the maximum of left max. Okay, for taking out the maximum of left max, I am just creating a container which is a variable that max equals to max equals to 0, left max equals to 0, because I have to create later on right max also. So it's very important to give the names of the variable nicely. So int left max equals to 0, I am taking height, I am operating this loop. Okay, so I am just taking left max equals to 0. So I am going to start from I equals to 1. Okay, so see how it will work, that left max of I is going to be maximum of left max and left max I minus 1. Are you getting this? Like I'm just telling you over here how this thing is working over here. So see, right now the array is in the left max. I have created the array. Suppose I have created one array left max over here. So the left max of array is, I have created the array of left max of the size of the container only. I am taking it, currently I am taking n, okay, for dry, just for the dry run purpose I am taking in this manner, okay. So left max of 0 I have declared it as, so you have to declare the left max of 0 as, left max of 0 you have to declare it as, suppose height of 0, okay, height of 0. I'm just dictating you, I know my writing is super clear, you won't be getting it, so I'll just explain you once again, but just see, just try to capture the things, or let me explain that much whatever I have done till now. Let me explain it, okay. First of all, whatever I have done, so like for dealing the question, the concepts which you would have got till now, that you have to take out the left max, you have to take out the right max, then you have to take out the minimum of left max and right max, then the water trap is going to be declared, and so we have to find these, we have to cover these aspects, and I have told you very clearly that how we are telling that what is going to be left max or the right max, okay. So now for generating the left max, I have created one array, left max of n, okay. It's the exactly the size of the array, or the size you are going to take accordingly, according to the constraints which is going to be given in the question. On the LeetCode you would see that the constraints are given, okay. I hope it would be clear. So see, now further how I moved over here, that I created a left max array of n size. Now the left max of 0 I have to declare. Do you know how to solve the question of buy and sell stock? Like if you do not know, then also there is no issue. If after seeing this concept now, you will get clear understanding of two questions. First one is of trapped rainwater, and the second one is going to be buy and sell stock. If you want to try that, then you would see that same concepts are over there also. So why I am taking the left max of 0 as height of 0, or you can take even minus infinity, it depends upon you. Why? Because do you think that before 4 there is any going to be maximum? No, nothing is maximum. So for left max of 0, which is the fourth element, it is minus infinity, or you can just tell that it's of height of 0 only. Then I am going to take maximum of left max and height of maximum of left max and, no, it is not going to be this, maximum of left max I minus 1 and height, it's going to be height I minus 1. I'm so sorry. So see, for the 0th element what will happen, that left max of 0 I have declared its height of 0. Now moving towards the next index, I am going to take in this manner. It now I is increased to 1. So left max of 1th, which is the first element of the array, second element of the array, it is going to be maximum of left max I minus 1 and height I minus 1. So maximum of, for this element I am taking maximum of left max I minus 1 and height I minus 1. So what is going to be over here? It is going to be, maximum is going to be 4 only, right? And you could see from the bar also that before 2 the maximum is 4 only, right? For the second element maximum is 4 only. And I'm so sorry guys, here we do not need to declare any left max 0. What I was trying to do over here is that I was trying to create the array, okay. I'm so sorry, by mistake I said that it's a variable. Now moving towards the third element, which is for this element I have to take maximum of left max I minus 1 and height I minus 1. Now you would be thinking that I'm every time I'm taking maximum, why? And left I minus 1 and height I minus 1, why? Because suppose if a student is standing in the line and I know the middle element is if suppose there is 3 students, one is Ram, Shyam, and take one more any name, Ghanshyam, okay. So Shyam is in between, and before Shyam, Ram is smaller in height, and after Shyam, Ghanshyam is having more height. Okay, it's taller than him. When I'm telling that which is, like when I took Shyam, okay, so I know that like if before Shyam I'm going to go in the line, then I know Ram is going to be already smaller, and in the next element for Ghanshyam I will be knowing that Ghanshyam is taller than that. So why I will for finding the smaller element, why I'll go to the Ghanshyam side when I know that the left max means, when I know that the Shyam is smaller than that, Ram is smaller than that, Shyam also. So I'll move towards that only. Similarly, it happens over here that if I'm taking maximum, if I have already taken maximum of the two, the next element which is going to exist over here is also going to be maximum. So this is already the maximum of the previous one. And why I'm taking height minus 1? Because if each time I'm increasing, suppose if for the 0th element I came, which is the third element, and suppose it would have got to 6. So for getting the 6th value, I have to take the maximum of height I minus 1 also. I have to consider it so that the right and exact value I get over here. So moving towards the second element, for 0, I am again telling to take the maximum of left max I minus 1 and height I minus 1. So what is going to be maximum over here? It is going to be 4. Moving towards 3, which is the first, second, third, fourth element. For the fourth element, again I am going to take the maximum of left max I minus 1 and height I minus 1 is still 4, right? Now for the fourth element, and you could see, like whenever you get confused, you just see over the graph, whatever the data which we are taking right now, it's completely correct, because just see over here, each and every time we are when we are taking maximum and comparing with the graph, for the 0th element 4 is only maximum, for the third element, for the third bar it's going to be 4 only, right? So the things would be becoming clear to you. Moving towards the fourth element, which is how much? 0, first, second, third, fourth. I am taking for this, for second. Now again I am going to take the maximum of left max I minus 1 and height I minus 1. So maximum of these two, it's 4 only. Now moving towards the last element, which is fifth, and it would be maximum of left max I minus 1 and height I minus 1. It would be again 4 only. So just check this side, does the data which we got is correct? It's absolutely correct, because you could see over here the maximum is 4 only. Now moving towards finding the right max. The second thing which you have to find is right max. In the same manner, the way we found left max, the right max is also going to be formed in the same manner. Again we are going to apply the loop over here. So first of all I am going to create the array of right max. Right max array I am going to create, it's 1, 2, 3, 4, 5. Altogether 6 elements we are having, right? So I have created the array of that size. And this time when we have to find the right max, means the element maximum, means what is the maximum element for this 2? It's 5. For this one it's going to be 2. So I have to take, this time I have to consider this element maximum, right? This time the loop will run in the opposite way. So I am going to again apply the loop, and before applying the loop, what I am going to do, that I am going to declare the right max of the last element, which is n minus 1. Right max of n minus 1, it's already going to be height of n minus 1. And I'll tell you a very specific reason, that you might be thinking why I'm not taking maximum as a minus infinity. Because since earlier what we were doing, that we were taking the maximum as minus infinity, minimum one. For taking out the maximum, we were taking it as minus infinity. So you will realize that when we do in C++, when minus would be there, so it would give a more larger value. which happens in normal addition also. But when this will happen, then also it is going to give the larger value only. That means this operations which is going to happen, then also it's going to give the larger value. That's why we are not taking int min or int max. Okay, now taking out, and I would suggest that don't take, because you have to apply if condition in that case. So instead of doing that, you could take the height of n minus 1 like this. So height of n minus 1, here I am telling is it's equals to right max of n minus 1 equals to height of n minus 1. So n minus 1 currently is 5. So 5 is going to be stored over here. Now I am going to apply the for loop over here, which will move from I equals to n minus 2, which is from this element, to how much? Till the time when I is greater than or equals to 0, or I minus minus. And each time what will happen, that right max of I is gonna to be maximum of, right max of I is gonna to be maximum of right max of I plus 1 and height plus 1 and height I plus 1. Okay, so it's going to be 5. Now moving towards I equals to n minus 2, and we are taking maximum of right max of I plus 1, which is this, and height plus 1. So right now I is over here. What is the value of n over here? It's 5. It's 6. So n equals to 6. Now 6 minus 2. We will start from this element, which is 0, 1, 2, 3rd, 4th, 5th. For the 4th element, the right max of I plus 1 and height I plus 1. So for this element, the maximum is going to be 5 only, right? Now moving towards the 3rd, again we have to take the maximum of right max I plus 1 and height I plus 1. So maximum of these two is still going to be 5 only. Now when the I is continuously decreasing also, when it comes to the second element, again it's going to be maximum of right max of I plus 1 and height I plus 1. So for the 3rd, we will again compare it with this element. So what is the maximum? 5 only. Now moving towards this element, for this also maximum of these two, it's 5 only. Then moving towards the last element, we have to take out the maximum of right max I plus 1 and height I plus 1. It's 5. And you have to see from the data also that from left max we really got 4 as the maximum, and from the right max we really got 5 as the maximum. So we took out the left max and right max. Now we, in order to take out the current water trapped, what we have to do further, that I am going to create int water trapped equals to 0. Wait a second. Now what I am going to take over here, int water trapped equals to 0. I am creating one variable where water trapped is going to be stored right now is 0. Now again what I am going to do over here, that I am going to, what I am going to do, I am going to find the minimum of left max and right max, right? You are not getting, maybe you would not be getting, because the question is a bit confusing. So let me just understand it carefully. See, for taking out the water trap, what we have to do, we have to first of all find the minimum of left max and right max. As I told you about the glass example earlier, that the water to be stored, you need to take out the minimum, and the minimum which you are going to get, it's the amount of water which is going to be stored over here. So you have to find the minimum of left max and right max, and when we have to take out for this particular height, we do minus height, means minus we do minus of this element, which is 2, minus of height of I. So now we have to take out the water trapped. So for this case, what I am going to do over here is, I have to again run the loop from I equals to 0 to I greater than 1 and I plus plus. Now each time what will happen, that I am going to find water trapped equals to water trapped equals to water trapped plus or you could say that you could just create, sorry guys, you could, it would be a bit confusing for the starting as it's the initial time, first time for you. So instead just create one more variable in current water. Okay, instead create one more variable which is current water, and you this time what you are going to do, that you are going to find the minimum of left max and right max, minimum of left max and right max minus, you have to just reduce the height from that. So I am going to show you that what I am going to do over here. Suppose the right max and left max over here is, let me just create again the left max and right max clearly. So left max over here is, it's 4 4 4 4 4 4. Left max is this, and then the creating the right max over here is 5 5 5 5 5. Okay, I have created the left max, I have created the right max. Now what I am going to do, that I am finding the minimum of left max and right max. Minimum of left max and right max, right? What I am doing over here is this only. So the minimum of left max and right max over here is 4. For the second element also it's 4. And what I'm in the same manner, I have created a current water variable. I'm just making it in this manner, current water. Okay, so current water is the minimum of left max and right max minus height of I. So I, right now I is 0. Okay, and minimum of left max and right max for the first element which we got is 4. Now I am going to reduce it by minus of height of I, which is also 4. So it is 0. Right? Now moving towards the second element. Now again for the second element I am going to find the minimum of left max and right max. So the minimum over here is again 4. Okay, so after finding the minimum of left max and right max, I am going to reduce it from height of I, because you just see the graph which I have created over here, that what we were trying, I tried to find the minimum for this one. I tried to find the left max and right max, and the minimum of left max and right max is going to give me how much water is going to be stored. So for this element, when I am going to reduce them after getting, suppose I got that from the left side the minimum is 4 and from the right side the maximum is 5, and so the maximum from left side and maximum from right side. So the minimum element out of the two is going to determine that how much water is going to be stored over here. So for that I took out the minimum, and now what I did, that I subtracted it from minus height of I, which is after getting 4 minus 2, I told that okay 2, that means 2 centimeter, 2 liter, whatever you tell, it's going to be the water stored over here. So see, similarly what I am doing over here, I am going to find the minimum of left max and right max, and minus I am doing over here a height of I. So height of I for this particular time, you just see over here, for the first element it's 2. So 4 minus 2, it is going to give you 2. Okay, so current water is this much, and if I am going to decide every time what the current water is, so I am doing max water equals to, I am creating one max water also, and if current water is gonna to be greater than 0, Then what we are going to do, max water equals to max water plus current water. I know now, right now you would have not got this concept, but let me explain you what I did over here. First of all, I did the minimum of left max and right max, and the value which we are getting over here, like 2, so we need to store it somewhere. And current water we are declaring for every step, like for every time it is going to renew its value depending upon the I which is shifting over here. So current water right now, in the max water I'll store 0. Okay, max water, one more variable I have created. So right now the max water is storing the 0 value, and each time what I will do, max water equals to max water plus current water. Current water, are you getting what is current water? Current water is the minimum of left max, right max minus height of I. So now after getting this 0, now it will go under condition, okay, current water is greater than 0, so max water equals to max water plus current water. Now moving towards the next element, which is I equals to, this will move, the loop will move to 2. Now minimum of left max and right max, again it's going to be minimum of left max and right max, again it's going to be for the second element is 4. Okay, so now 4, and what we have to do for current water, minimum of left max right max minus height of I. For the second element, height of I is 0. Okay, so 4 minus 0, it will give 4. So in the current water right now the value 4 has got stored over here, and now if condition would be applied, that is current water greater than 0. So yes, 4 is greater than 0, so max water equals to max water plus current water. Now 4 will also get added up over here. And if you are getting confused guys, just see this condition, that how much water is going to be stored over here, entire 4 water. That's what we are getting, because here no bar is there, so the 4 amount of water is going to be get stored over here. Now moving towards the third element, which is this one. Again we are going to find the minimum of in current water. Again the current water is again going to be declared once again, because current water we have declared inside the loop. So if current water, like now minimum of left max and right max, again it's 4, and we will do 4 minus height of I, it's 0, 1, 2, 3. For the third element, the height of I is 0, 1st, 2nd, 3rd, which 0, 1st, 2nd, 3rd, which is 3. So 4 minus 3 equals to 1. Now in current water the value 1 got stored over here. If now current water 1 is greater than 0, so it will get added up in max water equals to max water plus current water. Once again the 1 got added up over here. Now moving towards the fourth element, again we are finding the minimum of left max and right max, it's 4, right, minus height of I. Just check at the fourth index what is there in the height of I. It's 0, 1, 2, 3, 4, it's 2, right? So 4 minus 2 equals to, it's going to give you 2. Now in current water, now 2 is going to be stored over here. Now current water is greater than 0, so max water equals to max water plus current water. So again current water 2 get added up over here, and you can see the bar also, that here the 2 will get added up, because after taking the minimum of these two, the 2 is going to be added over here. So the whatever steps we are taking right now, it's completely correct. Now moving towards the last index, which is the minimum of left max and right max, it's 4. Again minimum of left max and right max is 4, minus I am going to do from height of I. So height of I in the last index, it's 5. So 4 minus 5, it gives minus 1. Now is current water greater, now in the current water minus 1 got stored. Now it will check, is current water greater than 0? Not at all. So don't add it. Doesn't it makes any sense? And you could see over here, like from 5 it give minus 1, and for at the 5th position it is not going to store any value, so it doesn't make even sense to add, right? So now we are going to add this 4, 5, 6, 7, 8, 9. So how much water does it get stored over here? So the max water is 4, 5, 6, 7, 8, 9. 9. Okay, so this was all about the trapped rainwater. Let me revise the entire concept once again. That what I did over here is that first of all I took the left max. I created an array to calculate the left max of the given height. Then I calculated the right max over here. Then I took because calculating left max and right max was important to determine how much water is going to be stored inside the valley. So left max I have taken out, right max I have taken out, then I have taken out the minimum of left max and right max, and I have done I have done whatever, like, yeah, minimum of left max, right max minus height of I, and here I have declared it water trap, but here what I have done max water. So the variable is same, means I was trying to do the same thing. It is water trapped only. Okay, earlier I have initialized over here with 0, you could see over here. So then we found that how much water is going to be trapped over here. So this was all. Now let's run this code. I'm going to show you. I have written the code in the leetcode. It's passing each and every test case, but let me show you, as it's very important to show you. Now see what I have done. I have created a left max and the array size I have generated this much. Why? Because as I told, the constants would be given over here. Whatever the constant, it's 2 into 10 to the power 4. I have just written 1 several times, but you could take 2 into means 2 and 4 0 means 20,000 you could take over here. Okay, and then left max of 0 I have stored as height of 0, and then I have compared it from the first element maximum. Then we took out the maximum of left max, and then I have created one right max, and then I have done, and it you could think of like here I have done height dot size minus 1, because right now I have created for this particular case when the height was given. So the array of right max is going to be exactly of the same size, but you could create according to the constant which is given over here. Okay, then I created the right max, and now I have took the maximum of right max I plus 1 and height of I plus 1. Okay, and then for taking and we have started from the last element. See, then I have taken out water trapped. I have stored it equals to 0, and then I have tried to find the current water. After finding the current water, if it's greater than 0, then water trapped equals to water trapped plus current water, and what you have to return over here, it's water trapped. Now let's run this code. See, it has passed all the test cases over here. Okay, let's submit it. So this is all for taking out the water trapped. I hope you would have got it. And just dry run the thing. When you are going to dry run, it will become more clear and crystal to you. Okay, just dry run it, because I have also dry run this question several times. I myself am a student, so I have also done, and I have dry run it several times. So this was all for today. Thank you, and keep learning, never give up.